Okay, we finally got to some of the real meat of the mathematics course, quadratic equations. But because it's so important, because it's so big, I've decided to do this one video where it's an overview. Basically what we're going to learn in the next 5, 6, 7 videos, something like that. So just to lead you through it, and then I'll give just a few slight examples in each of them. We're going to learn how to factorize easy equations. So that's equations that look like... So I haven't actually wrote any quadratic equations on the board, but this is what a quadratic equation looks like. And that would be an example of an easy quadratic equation. We're going to learn how to factorize ones that look like this, and we're going to learn other ones. For example, 2x squared plus, let's keep everything plus to make it easier for me. I'm making this up in my head, unfortunately, so bear with me, plus 6x. So that'd be another, that's a lot harder than that, but still, it's something we can do mostly in our head, to be honest, factorizing equations. We'll teach how to do it, some little tricks how to do it. But there's good news, don't worry. If you cannot do this way, some people are terrible at it. We have other ways that will work, just a little longer and a little more exact. We will also learn other ones, that like x squared plus 4x. A lot simpler, really very simple, but still factorizing. And maybe ones that look like x squared minus 4. Basically missing a number, missing an x. So missing the no x part, missing the 1x part, and missing the 2x part would not be a quadratic. Okay, so we're going to learn how to factorize them. That'll be the next video or two. I will probably split this into 2 videos. We will do, maybe 3 videos in fact. We will do factorizing these. That'll keep them a little shorter, hopefully. Factorizing simple equations with a with a 1 in front, with only 1 x squared. Then we'll look at factorizing ones with numbers bigger than 1. And then we'll do these together, perhaps, because these are quite simple. Very short video that will hopefully be. So that'll be 3 videos. Let's keep track of this somewhere. 1, 2, 3. Okay, then we'll move on, because I hate this. I hate it. Although we all learn it, and I'm going to still teach this one. Other parts of the course I say, I don't like this part, I'm not teaching it. I think you can do it without it. And that's true here. I don't think you need this because you have other parts. And if you learn the other parts, you will figure this out on your own. So bear that in mind, but I think it's just too big. It's taught too much by too many people that I cannot ignore this. But the reason I think it's possible to ignore it is because we have this method, completing the square. This works for every number. For all of these it works. For all of these work out quite nicely, in fact. I picked all these numbers to work very nicely. This one doesn't care. It can get fractions out. It does not care what is put in. It is brilliant. So let me put up one that won't work. X squared. Oh wait, I might end up picking one that it won't do. So let me be a little more careful. Let's just say plus 3x and then minus 3. Yeah, this will not be easy to do with this, but with the completing the square method, this will work fine. Let me just quickly in my head. 9 plus 12, 21. Yes, there's no square root of 21. Okay, this will be a messy answer, but still we can do it. We might have to learn about using square roots a little bit. Adding and taking away square roots. Getting answers that look like this, 2 square root 3 perhaps. Or maybe 3 plus 2 square root 3. So these are called surds. It's quite easy to deal with. We'll see them when we appear here. I don't think I'll teach them as their own class. So completing the square will work for everything. It'll work for these. These are very short if you know how to do it. Whereas if you do not know how and do this method, it'll take a little longer. But that's alright. If you do that multiple times, you will learn the trick yourself. So completing the square, I love this. This will be its own class. That'll be what we up to 4. Then I'll move on from this and we'll do quadratic formula. formula many people have said they have nightmares about for the rest of their lives because they always remember them. Minus b plus or minus b squared minus 4ac all over 2a. And this is when we're dealing with any equation with any number in front of the x squared, with any number in front of the x, and with any or no number in front of the c. This equation will solve every single thing. Just like this, it will. And just like this, it will involve some square roots. These are identical, by the way. I will spend 2 classes on this. I will prove this formula by using this, in fact. I will then show you how to use the formula. So that'll be 2 more classes. Now we'll be up to 5 and 6. This method is one thing I often tell some students that are afraid of all of these. Learn this first. This will guarantee you everything you want in the exam. You don't have to do any of these methods, but it's long, it's horrible, it's awkward. Once you get better at this, you'll start to go, wait a minute, I can do this some of these times. Wait a minute, I don't need to do this. I can do this some of these times. That's one way you can get through mathematics. Okay, and that'll bring us to a few little extra things at the end. That's the main things you need to deal with quadratics, all of this. But we'll do a few extra ones. We'll have quadratic inequalities. That's something like, I'll steal this one here, x squared plus 3x plus 2 is bigger than 0. Something like that. And then, first of all, it's quite simple. We'll do it the same way we do everything else here, except at the end there's a nice little trick to it. Instead of getting 1 answer or 2 answers, we will get a set of answers on the number line. I don't want to make a fool of myself and try and solve this in my head. 2, 1, minus 2, minus 1. I'm very tempted to try and solve it in my head. Let's see. We will. I can do this in my head. So 0 is not. If I put 0 in for x, I get 2 is bigger than 0. That is correct. So actually, here in my head, the answer to this will be every number not between minus 1 and minus 2. So it's a pretty cool, fun thing we have to do. And it's quite difficult. It would not be for every student. It would not be in every mathematics course. But just the harder levels, the more advanced levels, will do this. I quite like the answers we get. And then finally, that's another class then, is it? 7. Finally, we'll do a class on simultaneous equations. We've already done some simultaneous equations, but these ones will involve quadratics. So it'll be something like this. Maybe x plus y equals 4, and maybe x squared plus 3x minus 2 equals 7, or 0, or whatever. It doesn't really matter. Maybe we'll have 2 quadratics. Maybe we'll have not even quadratics. Maybe we'll have circle. Oh, there's no y here. I'm sorry. Put a y in there. Or, yeah, we will. The reason we need quadratics, well, you'll see when we do it. We'll need quadratics to solve any of these type of questions. In fact, I'll write another type of one in. Maybe x squared plus y squared equals 3. These are not quadratic equations, but we need to be able to solve them to do this. So maybe it shouldn't really be in this section. This is actually quite an interesting question. It's a circle and a line. And I apologize because maybe there is no answer to it. There probably is. They probably hit each other at some point. But sometimes we get no answers when they do not hit. Okay, that's it. That's my overview. Hopefully you're looking forward to some of these classes. You can skip ahead if you think some of them are things you want to do and you don't want to do. Skip ahead. Pick and choose anything you want. There will be, the next 8 videos will be all about this. You know what? I might change my mind on this. Maybe we won't call it part of quadratics perhaps. But this question would be more a good example of things we use quadratics for. But until next time, have a good one, and I'll see you then. Bye.